Hi guys, yeah. So I'm back. I'm back again today. Yesterday I started on bash scripting, so we still have like list of tasks here. And yeah, I just got back from CDS not long. Okay, so before I continue, I think I stopped number three, number four. Let me just quickly show some things I saw while learning and all. Yeah, so there are a couple of materials of learning resources I've gotten to know about since writing bash scripts. So this is one over the wire. It's basically you're a backend engineer, you are a systems person, or you a Linux person, you interact with the shell a lot, with the terminal a lot, or you just have some you want some things to just like a game to just test your knowledge and practice. So we have over the wire. It has a couple of war games. They call them war games, but then it's basically to test your knowledge of Linux, networking, and all the like. So Bandit is mainly uh Bandit is mainly for the shell and for scripting in the shell, and so you basically they have like a dedicated server for you where you SSH into, and then you perform the tasks. You play the game, which is basically using Linux commands, so which is quite nice, and I think it's similar to just something like this, but then you have like a dedicated environment or container for you to work on. It's like what I said. I actually wanted to like build later in this series, like a TUI for this project, and then having people interact with it through the web, and they get to like write their own solutions and see if it's correct as well. Yeah, and also I think I saw Linux journey as well. So learn the ways of Linux school is for you to like this Grasshopper, something like Workshopper used by Node School. So there are different like things if you want to learn about command line, you read and then you just perform exercises. I think it's quite nice as well. I think I saw this today, no long. User management, permissions, processes, all the things that you have to like learn if you are doing not low level stuff, but if you are interacting in the shell, learning about Linux, bash scripting, automations, and whatnot, networking as well. So I think I will be trying out these platforms as well when I'm free, just to like refresh my memory and just what jog my memory and then keep myself in the know when I'm free. Yeah, when I'm free because file system with this system can have a lot of things that are actually nice. I would networking numbers as well. I'll definitely be using this as well. So when I'm free and mostly at night, and I think I should also like try to like I don't know if I should stream it or I should just try to go through it offline and then maybe make a video about it. But then most likely I might just decide to just stream it these days because I think I'm in love with streaming these days. So to document over the wire, and then Linux. Ooh, I think I'll be dropping them in the description, YouTube description. Uh, since I'm just recording this, I'm not live streaming yet. Yeah, so before we just get back to all these, I think I should just go back to what I have for today and just continue with that. Yeah, so okay, here's my terminal. Yeah, I'm here. Okay, let me just do this, do this. Yeah, so we're back. Let me see. Uh, end this thing. Clear. LS. What do I have there? Okay, I have the solution. These are actually like the solution scripts that I wrote. And I noticed that in my previous videos, I was just solving the task. I was not actually creating a script for the task. So these are like for verification. So I'll just like rename these ones and then um write the task for solving each question like that. Yeah. So I just move one like okay, let me just show you what I'm doing now. Easy to pass through easy. It's not solution, verification, verify the bash. Because from the assignment that we're given as rice is write a script to perform the task and also a script to verify someone else's solution. So one easy verify dot bash. So which is like a script to verify the solution of that. So let's do this now. Yeah, so we don't have that again. Mm. Oh, let me. I think I should do shell expansion here. I think I should do shell expand. Oh, can I do it? Whereby I have to like just take two easy dot bash dot verify. Yeah, I think I can do it. So let's move. Um. Oh, can I? I'll be needing regex. I'm not too good with regex. I actually wanted to do something like this too. Uh, easy. The bash. So easy dot bash is common. It's just these two, three that is changing. So I think I can do move everything that has easy dot bash to everything easy dot easy verify the no, this is not how it worked. Okay, I'm moving. Okay. So there's no directory. I actually want to like rename. There's something we can do. I've seen it before. I've seen it before. Rename, move. Oh, let me just. Yeah. Uh, you remember the command I was trying to use? Is just it's something like this. Uh, I think it's like shell expansion, but it doesn't work that way. I just consulted ChatGPT and says apparently we just have to have use a loop. This my command is going to try to just move all files that end with easy.bash into another directory, whereby this is what I want to do. To have one easy.bash, two easy.bash, move them, rename them to easy verify.bash, and apparently we have to use what a for loop for that. So yeah, no, that's something to keep in mind. So for now, I will not use a for loop. I'll just move them or to okay, so how am I doing this? Let me just do this. Continue this. Two, two, and then three, because we have, I think we have three files already. Yeah, so let's, yeah, so now let me just try to like write the script itself, one easy the bash, which is vi one easy the bash. So such mode was the first script again. Create a file named report.txt in home slash student. So we have slash. We have our shebang bin bash. And okay, so we just cd home directory slash students, which means if student does not exist, it's going to create it for us. And touch report.txt. Yeah, that should work. That should be our script to perform the first task. Let's save that. And then vi2 is the bash. Uh, we enter in that mode and we have our shebang as well. Dash bin dash bash. And this is create a directory called logs and a file inside it named today.log. So wherever we are in the home folder, most likely, so we just make directory logs and cd logs and touch the log. That should be our script for that. We're making the directory.logs, then we enter into logs, and then we create touch.log. Yeah, that should work. Make you. So the third one, which we have a solution to check, it says move report.txt into a folder named archive. So basically, we are going to we have three easy.bash and let me just see. Uh, vi is to create the file in and then insert our then our shebang and then create move report.txt into a folder named archive. Initially, our report.txt is from this home, so we are going to do move slash home slash student into a folder named archive into archive. Initially we don't have archive, so we have to create that. So initially we have to make directory archive. That's the first script that runs, and then we now move home slash student slash report dot txt. We're moving that to archive. Yeah, so we save that. Okay. So now if we list, we have the solution script, one easy.bash, and then the verification script to check if our solution is correct. Yeah, so let's continue. So we have four now. Delete the file temporary.txt from home.students. So basically, we have vi for easy.bash and we have our shebang. Oh, enter insert mode. We have our shebang, and then how do you delete files in Bash again? Uh, again, this assumes that we have temporary.txt file already in the home slash students. So we're going to cd into home slash student, and we are going to delete. Wait, okay, remove, yeah, and remove. I was thinking, I went blank for a moment and remove temporary.txt, temporary.txt. Yeah, that should work. So if we run that, it's going to definitely delete file. So right now we're going to write the vi for easy verify the bash. Uh, which is to like check the correctness of what we wrote if we enter insert mode slash bin bash. And how do we check? That means we just have to what go into the home folder, home slash net folder, and check, ensure that there is no file called temporary.txt. So we are just going to cd home slash student, and then oh, if we cd, then we're going to write an if statement to ensure if file temporary.txt. When you're writing if statements in bash, you can this square bracket can actually be doubled. But also in sh, in shell command, single bracket also works. If this is true, then you cook beans. Then echo you cook beans, bro. File still exists in here. Else echo else echo correct. Uh, doesn't exist, and then fi. So we are done. It's funny. It's like in Bash, if what in like commands, like you have to like when you are done with the command, you have to like invert it, like if statements, you have to end it with fi. Um, case statements, like all the switch cases, you have to end it with isak. So I used to see some kind of names on Twitter as well, whereby they say today Ed Not is like Tunde but in reverse. I was like, oh, maybe this person actually did a little bit of bash scripting. I've seen I think this guy Igwe and then Igwe. I was like, and then I think Fortune 2 has done something like Fortune Entronoff or something like that. But like, oh yeah, this is actually nice. I guess they did some bash scripting or some Unix had been by Upsha. Yeah, so I think we are done with that. So this f flag command actually returns true if that file exists. So if it returns true, then good means, but if not, then correct file doesn't exist. So we have that. And then let's move to the next one, number 5. Count the number of lines in note.txt using NWC, which means here we are assuming that we have a note.txt file already. But right now, here where I'm working, we don't have a note.txt file. So okay, let me write the script first and then let me generate a notes.txt file. So we have I think we're on number 5. 5 easy the bash vi and then search in bash. It's a simple command. WC is known as like word count in bash. So if you are counting the number of lines alone, it has 3 flags mainly, which is WC flag L, which is to count the number of lines in a file. We also have like WC slash M, I think it's M for character count, M or M, and then we have WC slash um C. Is it C? Because no, we are counting number of lines, you are counting number of characters, and you can count number of words. So it's WC, L, WCM, WC, flag, W to count number of words. But right now we are counting number of lines. So this is just the script for that. WQ. So let's generate uh notes.txt file. Vi notes.txt in here. So let's just dump. Oh, do I need this? Is it not file? Let's just hello. Oh, start mode. Hello. My name is Festus. Um, writing bash script. So I think this is good. Okay, I think I have spaces. Let me remove the spaces. Uh, I, I, remove the spaces. Another way we could have written that is just to do echo, write the script, blah blah, put spaces into the file. But I just decided to use VI to make the note. So let's now run our script, which is to run a script, you just put dot slash 5 easy dot bash. So this should return to us the number of lines in the script. Okay, I think I'm missing something. I didn't pass. When you write the script WCL, you have to actually pass it the file that you actually wanted to count. You know, when I wrote the script, I didn't pass it the count. Let's check this. See, it didn't run anything because I didn't pass the notes to it actually. So I'm just gonna do that, and then declare vi. So we just have to what pass notes.txt into that. So escape. Okay. So let's rerun it now. 6. So we got 6 and then we got notes.txt. I don't know why it returned notes.txt. Okay, let me just do something. WC, let me write it here. L notes.txt. Oh, so 6 and then notes.txt. Okay, what about WCL? Doesn't return anything. Notes.txt. So interesting. So return 6. Oh, normally you shouldn't do that. You don't return the number character count. So the other time I was talking about character count. Okay, that's number of lines. And if you check, if you do cards notes.txt to check the details, you see 1, 2, 3, 4, 5, 6. That's 6 lines. Yeah, so if we do wcm notes.txt give us a character count, so which means there are like 51 characters in notes.txt, and then the last one is wc w that should give us notes.txt, that should give us word counts. So there are 9 words. If we check 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 words in our notes.txt file. So I don't think we've written a solution for that. Let's write a solution for that. And I think you know the solution for that will go. That's 5. Easy. Verify the bash. And we have our shebang. Oh, I've not entered insert mode. Try to. I once took a course on Vim, introduced to Bash and Vim, and since then I've not actually had to like use Vim regularly, and that which is why I'm actually writing in Vim right now to try to like bring back the things I learned in the course, and yeah, I'm not using like my VS Code or something. Hopefully one day I'll become a power user and be like, oh, I live in Vim or Nano Vim or Nano, and like, yeah, so we're writing a solution for 5 to count number of lines in notes.txt. How do we write this to verify that someone, what the person wrote is actually correct? Do we say, do we actually run the script first and see if the answer is not equal to 6? But now I'm the one that created node.txt. You can Anybody can come and create a different node that I actually don't know the number, which means for a solution of this, you actually have to what also write your own code to count the lines, and then you compare the returned solution. That's what I'm thinking. That's what I'm thinking. Okay, let me see this to just verify count the number of lines. Let's go to ChatGPT, and I've written a script to calculate to output the to solve these. Now I want to write a script to verify that my solution is correct. Right, that. Yeah, this is what I did. Now let's write a verification script that checks whether your solution is correct. So expected output Okay. Oh, okay. We already have notes.txt. So which means we are also like going to have the same command. So it's same thing what I said. So to verify it, we're actually going to run the person script. This awk will still get there, sha. So and then compare now be like yeah. So actually compare if actual output is equal to expected, then our echo correct line count is actual output exit zero because it's successful. And exit code in bash zero is like success and exit code of one is like failure or error. Yeah, ex- expected, forgot. Yeah, this is nice. And then some explanations. Oh yeah, so this awk is like for filtering and extraction, which means when I ran the script, it showed the number and then it showed the file name, which is not.txt. So the awk is just to extract the number parts from the output. Yeah. Awk print one, and print one is just like the first argument uh in a terminal. We have like positional parameters, yeah, which is just that's the first positional parameter there. Print the first positional parameter there. Or just the number parts. Yeah, it's the positional parameter now, like the first thing. Yeah, so let's I think it's easy now. Why did they actually put bash? Is it because is it for them to know that this person is actually like executing a script? We get, and this one is piping. We're piping the answer to that. Uh, yeah. So I think I'll just do that. So we have a variable name. Do need to specify. Have expected is equal to wcl notes.txt, and then returned returned output is equal to be running your bash script. Uh, some bash. Let me not put bash initially. Our script that we created is 5.5 easy dot bash. Then we pipe. This pipe is like you are taking the output of a command of a command and you are making it an input into another command. You get, so the output, whatever the output of this script is, which is the number and then the file name, we are putting it into awk. We have for doing filtering and likes awk said grep and likes awk. Why did you put print positional parameter one for doing this? Close. So then we compare if let me use double stuff. Normally I use that if expected there's no space is equal to returned output, then echo maestro. No, just simple thing. Echo. Good. Solution is correct. Else echo. Hmm. You definitely mixed something up. Yeah, F5. Yeah, so we have our expected because we get to write the command and then the returned output to which we get from the script, and then we just compare them together. Mm. Oh, what's the solution again? Okay. There is something here. because we're actually getting nodes. We are writing our own command, which is inside another script. Uh, this less than is actually saying this we are feeding notes.txt into our command, like we are taking it to std in. Yeah. Mm. Yeah. Let's just try it out like that, like that, like that. I think actually put this in quotes. Let's see if this works. First, let's put WQ VI505 and just run it. Okay, print unexpected simply good solution is correct, which means did he actually check it out? Because I was getting error here and still got to output stuff for me. So let me just fix that real quick. Oh, enter insert mode. And actually for my live stream I was thinking of using using Twitch. Yeah, good solution is correct. It verifies it because it ran our script. So which means we can actually run our script without actually adding bash here. Just run because we're in the same directory, run it. And actually we can this runs this WC listing the number of lines notes. It actually also works without actually piping notes.abi, sending our notes.txt into std in. Yeah. We're making progress. We're making progress. So just like this, I it's similar to all those over the wire games and lineup stuff. So next thing is still easy stuff. I'm planning to do the intermediate and expert stuff as well. I think it should move faster. Uh, change the permissions of data.txt to read only for all users. Okay, which means we have a data.txt file already, and then we are going to be using the chmod command, which is it for changing permissions, file permissions, and all. So 6 easy the bash vi, we are creating it and then writing the script inside. Okay, w oh I wrote 5, this is 6. I have been the bash. I think I'll just do an hour wherever we get to, then maybe I'll move to the intermediates and then move to the advanced ones to just really test my skills. Um, change the permissions of data.txt. So I believe we are in the same folder where data.txt is. So just do chmod um to read only for all users. So if you want to add permissions, you do plus to add a permission and minus to subtract permissions, right? To the user groups, we have UGO user, we have the users, we have the group, and then we have the owners, right? I think so. So and then we have the RWX, the read writes stage mode, the read write permissions. So it says to all users. Normally, if you want to apply to the user group, you can just do u minus x, not the so only the user group will not be able to like execute the file, or ug minus r not be able to read, minus w not be able to write. Oh, so the question is change the function of data.txt to read only for all users, so all the user groups. So we have the ugo minus ugo minus w minus x minus r plus r. What do you think of this? Is this correct? So video minus w minus x. So they only can read, which is the data.txt file. Yeah. So let's do this. And let's confirm. Let's create data.txt file. Touch data.txt. So ls. So we have our data.txt file here, and let's check the permissions for data.txt. Ls a. Oh, let me just clear ls la to check the long list of the permissions. So as you can see, this is a directory. It has a read write. Mostly all users, the user, the group, and the owners, they all have read, write, and executable permission. And when we check data.txt, it also has, it's not a directory, it's a file. It has a read, write, executable, read, write, executable for the user groups. Now let's run the script. That's 6 easy dot bash. Yeah, let's now ls la. If we check our data.txt file, we have r w x r w x r w x, which means it's removed only the ability to write. It didn't remove the executable function, which means our script is wrong. So let me fix that. Oh, minus. Oh, sorry. I think this is it. Minus w minus x. So we are removing the. So let's run the script again. Let's see. It still has the executable. Let's now run our script. So clear ls la. Oh, it still has the executable. Wow. We want it to be read only. How does this thing work again? Let's do minus x minus x minus w sq pq clear on the script and lsla. It's only remove w. Let me go to my script and just remove this w sq pq on our script and lsla. See this here. How does it work? It wants to be executable. Yeah, so I just I just confirmed I'm running in WSL, and from the settings it makes all files executable by default. So which is why it only removed the write access, and it didn't remove the executable here. So which means my this code is essentially correct. It's going to remove the write access, it's going to remove the executable access, and it's going to leave it as read only. And this only works because assuming that the file already has read access right from the beginning. Because if the file doesn't have read access from the beginning, which that means essentially means our solution is not correct. And another solution that I saw uh, is this using Unix number-based operations, which is like chmod, 444 data.txt, where in the Unix numbering system we have base 8 numbering system, we have 4 to represent read and 2 to represent a read access. 4 is read access, 2 is a write access, and 1 is an executable access. So something like 4 4 is like the user group as the user, which is like the owners, they have like read access to the file. Because there's no 2 and there's no 1 after, they do not have like write access and executable access. Then we move to the group users, which is also has 4 read access, no write access, no executable access. Also, the other people, they also have only read access here. And yeah, essentially, let me see if this oh oops. If this works, that means this overwrites the um LSLA. Yeah, so basically it's still the same thing. Oh yeah, I ran the script and then I ran it. So my WSL is like overwriting our script. Sure. So right now we have to write a solution to confirm. Oh, I think I jumped. Okay, I didn't jump. I didn't jump. We have to write a solution that verifies that our script is correct. How do we do that? Change the permissions of data, which means our scripts, uh, basically, we might not. I don't think at the academy they were expecting us to do like a deep check. One way to just verify is if after running the script, if the permissions has changed. So basically, yeah, just run the script and see if the permissions has changed. If the permission hasn't changed, then the script, if just run this in our solution script, we are going to first of all run the script, the user script, and we are going to check the file permissions after running the script. If all users still have like executable permissions or writable permissions, then the script is wrong. But if they don't have that, if it's only like readable permissions that they have, then our script is correct. How do I write that? How am I sure I know how to write that? Vi 6 easy solution dot bash our shebang. Oh, insert mode. Enter insert mode. Uh, our shebang, and then we run the script first. Uh, we just run the script. Um, output returned permissions. Basically, we run the script, so we just say slash 6 easy dot bash. After we run it, then we see if I don't know how to check file permission. So if how do you check permissions of a file of a single file? How do you just want to check? Oh, I think there's a command. If it is readable, data.txt. But then, if it's readable, we don't know the user group that is actually reading it. If we have to use this command, let me just check ChatGPT. I think I did something in there with ChatGPT, which I didn't go over to read. Uh, Okay. Start. I think start is a command I've not used. Start C string A data.txt. We're actually getting the actual permissions in octal format. Expected permission for read only is expected permission is 444. So we are going to compare. Oh, if actual permissions equals to expected permissions, then correct permissions are actual permissions read only for all exit. Okay, I think it's good. What is start? Start returns permission bits in octal. Start. Let me just see start. Let's see start. Let's um WQ. Let's see man start. Display file or file system status. Let's now see formats. We're using this -c flag format. Is it specified format instead of the default output format? Okay, so it's basically start. So permissions. The valid file format sequences for files without file system. We have a permission bit in octal. Okay, permission bits in variable format. Okay, we use these permission bits in octal to see if it's equal to 444. This is quite interesting. Like this is really interesting. Um, Man is just like checking the manual, the start manual, and how to use it. Okay. So I get why you use start to check file system details, and then .c is to print the output, format the output in octal. Yeah, A in octal, C A in octal, and then we pass the file that we want to check. So start. So we just see it's just like comparing the actual permissions using Linux command directly, and then our expected permissions from running the scripts. Oh, okay. Which means we are not actually to run the script. If the script should have been run, so we just come and check the permissions. So actual permission is this because we are checking the data.txt file currently, and then the expected. We know that is only readable. We are expecting a 444, and we compare. So let's just do that. Let's do that. And I know that in Bash, strings here does not really matter here because if you actually because these are variables, if you just put it in directly, it's going to take it directly and just compare. Uh, yeah. So let's. I don't want to copy. No. So, wow, there are a lot of things. That's just something about uh things. Q to Q to Q to. So there, a lot of things you can learn from just using man. So I used man to check stats, check the manual of stats command. So let's go back to VI solution. So I think you don't even need to like run the script because we believe the first script should have been run already. So we just come and check the permissions. So the expected sheet. Okay, let's do the um, output from that is equals to start a file format where we want to like the way we want to like output the format. Start is just to show like the file system permissions dot c in octal data dot txt. Uh, yeah, let me do something. Echo output just to be sure. echo output. That's a variable. That's how we call variables. And then now compare if. Okay, we also have a expected. Have expected permissions. Expected file permissions. Expected equals 444. Again, I'll see if the string is actually needed, and if um output is, is equal to expected, what's this? This now doing is crazy. Oh. Then oh okay. Oh okay. I was asking like where is my color coding sheet coming from? Hmm. If output is equal to expected, then echo correct file permissions file set to read on there's output else echo lava expected expected Bogo output if I didn't close my string. Yeah, so let's check this out. So right now I know that I'm in WSL and then I can overwrite the um executable. So this should be wrong. So let's LSLA. We know that we only have readable executable to not writable, which means this is wrong. But if we are running this somewhere else, it should be correct. So let's run our script. Fix easy verify.txt. No, the path. Wow, it is I don't have ah ls. Oh, I need the solution. Oh, just move six six easy solution the patch to six. I did tap completion. It's easy verify the patch. So ls we now have six easy verify the patch. So we got 555, which is four, which is like the four, which is a readable, and one, which is the executable. Four plus one is five. 555, which is it is readable and executable. Expected five. So it's actually like correct. No, the script is correct, but you get. Uh next question 7 says create a hidden file named .secret in the home directory. Well, I don't know how to create a hidden file. Is it hide flag? A file that is hidden. Let's just do file system touch. See, let's do man touch. Is there something like Eden? Eden. Nah, they didn't put something like Eden in there. And I do not create any file. F ignored each no difference. Affects each symbolic link instead of any referenced file. Wow. Well, let's quickly see how to create inner files in Bash. Oh, so you just putting dots in front of it create an hidden file. Wow. This create a file in the current directory. So we shown. Wow. So, oh my God, how can I forget? How can I forget? Dot hidden f file and hidden config file. Make directory, create a hidden directory, edit a hidden config. Wow, so simple. So I've learned that today. Cute quotes bin. So we do vi 7 oh 56 minutes mark easy dot bash and insert our shebang bin bash. It's been fun doing this. It's been fun doing this. Still have lots of things to do. We still have the intermediate script, we still have the expert script. I think I might just work on them on my free time, write them, and then uh walk through them later in my later video so I can actually like go over everything. I think that's what I'm going to do because I actually want to. After this 1 hour, I'm going to have like another hour of recording or streaming, where I've actually solved all these, and then I'll just walk through the solutions. I think that should work because yeah, let's just finish this. Let's just finish this. Just touch the secrets. So simple. So simple. They even said it there. Uh, create a hidden file named the secrets. They even put everything there in the home directory. So let's see the home and touch secrets. Uh, WQ. So how do we verify something like this? Uh, verify. Our script should be something like enter insert mode now. I bin bash. And that's supposed to be like cd home ls dot secret. Wow. Okay, let's just do this. Remember our code escape to see if a file exists. Clear ls. If a file exists, which is the first one. Vi one easy verified txt verified of bash. So this cd into home. Then if this exists, then file exists. Else file doesn't exist. Let's see if it's checked. That is secret. Well, how will we know that there's actually a secret file? Which means we then do an lse to show secret file. Okay, so let's just do lse to show the secret files and then check this. So let's copy this. Boom. Is it a verify? So let's just do cd home and lsa to list all files, then paste to dl. Oh, escape d escape dl. Oh, da. Let me enter insert mode, Jerry. I'm just learning this nigga. Sorry, that's the that. So if f dot what's the file name dot secrets, then secret file exists. Secret file doesn't exist. Let's try this. So let's run the bash. Let's uh run it. Seven easy dot bash. We've run the file. Let's cd home. Let me just copy this. See, cd home. Oh, sorry. cd and ls. We see there's no secret file. Let's see lsa, and now we see a dot secret. Clear. Let's now go back to cd this, and let's run the verify script. 7 easy verify dot patch. Boom, 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 boom. Let's see. Because I told it to enter, so it entered. That's why it listed this, and it says secret file exists. But now I should edit it so that it doesn't like actually enter into it. How does that work? BI7 is verified. Oh, it doesn't have to list. It doesn't have to. It doesn't necessarily need to list. Wait, which means this is going to work. Yeah, this is going to work. Or just move it here. If slash home slash dot secret. Oh, okay. If there's a file called home slash dot secret escape public queue. So let's do it again. Secret file exists, so that works too. That works too. That works too. Wow, it's been an hour long, and thank you for sticking to it. So there are still a couple of those are just the easy challenges. I'll try to work on the intermediate challenges and the expert challenges as well, and then I'll try to create. I actually want to create a TUI for this. I actually want to do it live. I want to make a record of that. Maybe I'll just do it too and then upload so you can see that as well. I think these experts level stuff are still like kind of using some advanced bash commands, some advanced scripting, and this is where the fun starts from intermediate and then to expert questions. I think right now I'll just go to focus on the assignment I was actually given at Rice Academy, which is this 4 and 5, and I've done this one. Rename all .log files in the directory to log back, which is easily what I did today. I think I'll just be using a for loop to move, and then the expert one says create a systemd service to run a bash script startup. So I'm going to be using systemd to create a service to run a bash script startup. So I think I'll start off, I'll write a bash script to say, welcome user, welcome Festus, or welcome Mark or good afternoon Festus, good afternoon that. I think I should do that for And then this five, sorry, I'm not, I'll just be writing a verification script for this. Count the number of lines in node.txt using. Oh, this is my own set. Oh, write a script that checks if file exists. I think I've done that today. Write a script that compares two files line by line and shows the differences. Oh, this I'll be using diff. Diff diff is a Linux command that helps shows the differences between files. So diff will just do that for me. So in that expert level. And D6, I'll be writing a script to verify if the solution that this person submits is correct. Change the permissions of the. Oh, I think I already did this. And write a script that accepts a file name as input and print its line count. File name as input. So we are going to do read. We are going to read from stdin.r or use read, and then whatever is the file name, we are going to take it as the positional parameter, and we are going to just do wcl the positional parameter slash what is it called hyphen the whatever is being read from stdin. And yeah, so how am I going to verify these? Uh where is it safe? The six. Accept a file name. Mm, how to verify that it's actually reading from? That is actually reading from SCD in, and also create a cron job that backs up a folder every day at 2 a.m. I've actually not written cron jobs in Bash, which is something I'd actually love to learn. So yeah, thank you for sticking along. Don't forget, I dropped a couple of materials at the beginning, the Linux full and then over the wire for practices to improve your Bash skills. Yeah, and that should be it for now. I'm going to see you in the next video. If you are still here, kindly subscribe, like, share, subscribe to my channel, and see you around.